All right, today we're jumping into a huge topic in sterile manufacturing, the EU GMP Annex 1 requirements for a contamination control strategy, or CCS. And let me tell you, this is way more than just ticking a box for an audit. It's a whole new way of thinking about quality and control. So let's get right into it.
This quote right here, it just says it all. The 2022 revision of Annex 1 was a massive shift, and this marks the end of an era. That old way of thinking, where you just test a few samples from a batch and kind of cross your fingers, yeah, those days are officially over.
The whole philosophy has done a complete 180, flipping from reactive to proactive. It's an official admission that, statistically, you just can't catch every problem with end product testing. You can't test quality into something after it's made. You have to design and build that quality in from the very first step.
So, how do we build this bulletproof strategy? Well, we're going to walk through 6 key parts. We'll start with a new paradigm, then look at the CCS as an ecosystem, fire up its engine with risk management, dive into container-specific risks, check out our engineering defenses, and finally, see it all as an evolving fortress. Okay, first up, a new paradigm. This is all about leaving behind that old, simple logic of, hey, my environmental plates are clean, so we're good to release the batch. We're moving away from just watching what happens to actively controlling what happens. So, what even is a CCS? It's definitely not just another document to stick in a binder. Think of it as the complete story of your facility. It has to connect everything, from the air you breathe in the clean room to the way people gown up, and explain the why behind every single control. It's a living, breathing narrative. And that idea of a narrative brings us right to our second point, the CCS ecosystem. This is where we stop seeing the CCS as a simple checklist and start seeing it for what it is, a dynamic, living system where everything is connected. Now, this is absolutely critical. Your strategy is not a set-it-and-forget-it project. It's a living document that has to change and adapt. You get new data, you see a new trend, you install a new machine, your CCS has to evolve right along with it. So if it's a living system, what powers it? What's the engine that makes it all run? Well, that's section 3, the engine of control. The whole strategy is driven by quality risk management, or QRM. It's simple, really. You can't control risks you don't fully understand. In your risk management toolbox, you've basically got 2 superstars. On the left is HACK, which looks at your process step by step. A great example is a depyrogenation tunnel. That's a critical control point, right? If the temperature drops, you have a problem. On the right, FMEA is about what could go wrong, especially with people. What's the risk if an operator's glove rips? FMEA helps you figure that out so you can focus on the biggest dangers. Okay, so let's put that risk engine to work in our next section, container-specific risks. Because let's be honest, a one-size-fits-all strategy is just a recipe for failure. You absolutely need tailored plans for every different container you work with. Let's kick things off with Ampoules. The big challenge here is fusion. We're talking about melting glass to create that perfect seal. It's a pretty intense process, and, you guessed it, it creates some very specific and serious risks. You've got a few major worries. That intense heat can actually char the product, creating black spots. You can also create tiny glass particles. But the real kicker is the risk of microcracks that are basically invisible. And for that, the control is non-negotiable, 100% leak detection to make sure every single unit is sealed tight. Next up, let's talk about liquid vials. You might think the biggest risk is during the filling, but actually, it's in that little window of time between when the stopper goes in and when the final seal is crimped on. I like to call it the capping dilemma. See, just because a stopper is in the vial doesn't mean it's sealed. It's still vulnerable as it travels to the capping station. To solve this, Annex 1 is very clear. You must have a grade A air supply, which is basically a protective curtain of ultra-clean, HEPA-filtered air guarding that vial until it's completely sealed. And now for the big one. Lyophilization, or freeze-drying. This is probably the most complex and high-risk process of all. You're loading thousands of partially stoppered, open vials into a chamber. It's a huge open door for contamination. So the controls here have to be absolutely ironclad. The #1 thing you can do to reduce risk: take the person out of the process. Automate it. But you also have to think about hidden risks from the machine itself, like oil coming from vacuum pumps, which means you need some pretty sophisticated monitoring to catch it. So we've identified all these risks. Now let's talk about building the walls to keep them out. This is all about engineering your defenses, and we're going to focus on the two main technologies that separate your product from people: RABS and isolators.
So here's the matchup. On one side, you have isolators. These are the gold standard. Think of them like a high-tech bubble that's totally sealed off. On the other side, you have RABs. Now, they're a great option, especially for upgrading an existing facility, but they require more work and a cleaner background environment. The verdict from Annex 1 is pretty clear, though. If you're building new, you should be building with isolators.
Okay, let's pull all these threads together in our last section, the evolving fortress. This is where we hammer home that central idea. Your CCS isn't a project you finish. It's a fortress you're always reinforcing.
Which, of course, brings us to the one question everybody wants to ask. After all this planning, all this work, when do you finally get to check the box and say, okay, we're done?
And the answer, maybe not surprisingly, is you don't. A CCS is never finished. It's a continuous cycle. It has to be reviewed at least every year to look at new data, to analyze trends, and to learn from what's happened. It's designed to get smarter and stronger over time.
And at the end of the day, that's really the point of all this. The goal isn't just to pass an inspection. It's so much bigger than that. By doing all this, you are building a fortress around your product. You're doing it to make absolutely sure that what you make is safe for the patient at the end of the line. And that is why this all matters so much.